But if at the end you're on a tight deadline and you've suddenly got to collate all of this information 10 minutes before something's due, then it can get very stressful, and you'll miss things as well that you've been doing as you go along. So
don't we all know the mad rush of reaching the finishing line? But getting started early doesn't need to cost a lot of effort, in particular when it comes to data and software safety, the theme for this bite-sized class and episode, with my guests Ellie Sheppard, who you've just heard, and Madalyn Hardaker, both from King's College in London. If I were to summarize this particular bite-sized session, it would be this: better safe than sorry. And I wish I could give you a simple recipe for how to make your code and your data safe, or safer. Alas, things, as per usual, are a little bit more complicated. For, as we will find out in this episode, it all depends on your project, what it does, and who it is for. Some projects actually require a full and formal safety assessment, usually involving auditors and quality and safety professionals. An example of this would be an application used in clinical environments. But at the other end of the scale are applications or libraries that are only used for a specific research project, sometimes created by one researcher or a small team. The app or library may not even leave the lab, running, for instance, on a local computer. And in cases like this, thinking about data and software safety may take a very low priority, if it is considered at all. And you may think, why not? I mean, after all, if the app I created runs only on my local computer, what could possibly go wrong? Alas, as my guests Madalyn Hardaker and Ellie Sheppard from King's College in London will point out, we never really know what will become of that little script we once wrote to make our life easier. It might turn into something much bigger, involving a lot more people and having a wider impact. But even if the data and the software we created won't go anywhere, we still need to make sure that we keep our stuff safe so we can access and work with it again at some later stage, say when we sit down to write the paper about our research work. If you've taken the online course, Ellie and Madalyn will have given you some hints on what you can do in practical terms. The main principle is to build safety into building software and handling data right from the start. In other words, security by design. And doing that doesn't have to be complicated or even take a lot of time, as Ellie and Madalyn will explain in the following conversation.
Hi, I'm Ellie Sheppard and I work at King's College London as a data governance manager, and I'm currently working on a project called Ferris AI, which is using biological data to help with cancer care for researchers. I work under Madalyn, and we are very interested in data compliance in the research software area and how to make it more secure, and assisting researchers, software developers, and anyone in the space with governance requirements.
Excellent. Madalyn.
Yes, thank you. So I'm Madalyn Hardaker. I'm head of e-research data governance at King's College London, working with Ellie. I have been working in the data governance space for nearly 10 years now. It evolved from more clinical research type work, and I fell into it a bit around the time of GDPR, and when data compliance started to get a lot more attention, I think, in the mainstream. And I must say, it has absolutely become a passion for me. I think that there is such a role for data governance in all sorts of research, of course, but particularly in this software development space, as Ellie mentioned, something that we have taken a big interest in, and ourselves are getting more up to speed on how we can best help and support people building and producing and using software, particularly in the kind of academic and research space.
Ellie, I think you mentioned the key word that I would like to start our discussion with, which is security. In the context of software, what do we actually mean when we say secure software?
When we say sort of secure software in a research context, it is about protecting what matters most to you in your specific context. Not necessarily, it's not always just thwarting, those hackers and those bad actors that are going to come in and try and get into your system. It's thinking about within your software, within your data, what matters to you and how you can protect it. So that might be the integrity of your results, your reproducibility, and the confidence that you have in your own work and your own data set, and really looking at those aspects and the best way you can look after it and protect it from technical measures, people measures, and looking at your software from all those different angles.
Madalyn, is there anything you would like to add?
Absolutely. So like Ellie said, it is very context specific, but when you start to think about what you're doing and the impact that you're trying to have with the product that you're creating, you have to just also think about what the unintended consequences might be as well. And so when I think about secure software, I think about really optimizing that usefulness while also minimizing the potential for any downstream harms or unintended negative consequences.
Right. How can software engineers go about this then? So anticipating the kind of dangers that may lie ahead, shall we say?
Again, it's going to be very context dependent, but always talk to whoever the subject matter experts are for their perspectives. It may be that you, the developer, are a one-man band filling all those roles of expert and builder and creator and all of these things. But in that case, I would still recommend getting perspectives from other people in your field who may have another angle to the kinds of questions that we would ask. So some of the questions are, first of all, what are we protecting? Is it intellectual property? Is it data? Is it models? AI models are obviously a big thing these days and their outputs, infrastructure. So all of these things have value. And so we want to make sure that they are optimized and harms reduced. And so identifying what those assets are is always the first step. And then who are we protecting it from? You have to assume that people will make mistakes, assume that people are out there who may have ulterior motives. And so we have to accommodate, all of those kinds of scenarios. And oftentimes it is small patterns that we can thread throughout can help to support our defenses against all of those different things. So it's important to think about them all. But quite often, it's really very simple things to implement that can make the biggest difference across the broad streams. And we can talk about some frameworks and things to look at to see what you can pull from there, where people have done the heavy lifting thinking for you in putting together checklists and toolkits and things.
I think we probably come to that a little bit later. But before we do, there's another point that I'd like to make, and that is that a lot of people that write software in research, that nowadays we do have professional research software engineers who are trained software engineers, but often you get software engineers that aren't really software engineers. They're researchers who suddenly fall into coding, so to speak, right, because of the needs and the demands of the job. So how does your data governance perspective then shape the way you think about secure development?
Yeah, both of us come from a data governance background as opposed to a software development background. And I think for us, that really leads to a risk-based approach. Everything we do and all the projects that we're working on and that we get involved with, the first sort of things you should start thinking about in our heads is what are the risks here? Like Madalyn has mentioned before, these are very, very context specific. So for some people, they may be more concerned about outsider threats, some more internal. There may be lots of different things, but really having that risk-based approach, sitting down and thinking about what could go wrong, what is likely to go wrong, what is unlikely to go wrong, but if it did go wrong would be absolutely terrible. And looking at it from that perspective, I think really helps when considering the security of your software development, because you know where you need to focus your efforts then by identifying your key vulnerabilities, the key risks to your software. Yeah, then you know where you can focus your time and focus your efforts, which can be very useful when it is these, one-man teams or smaller teams. Yeah, I think that's from our data governance backgrounds. That's what, for me, really comes forward when looking at this kind of thing.
I would just add how software can evolve and be repurposed and be built upon for other projects. given that fact, it's something innocuous can become itself or become a dependency for something even more consequential. And that's excellent. That it's great to find out that something that you've built has the potential for greater impact. From the outset, if you're thinking about things that will make your code, your systems more secure, things like having good documentation, having good accountability in place so that you know who made decisions and why they were made, those sorts of documentation and governance type pieces done early on can really lay a strong foundation and a good framework for if that project grows or becomes something useful in other domains or useful in other contexts. The flip side of that is, you need to know what your foundations are so that when they're built upon, that you don't introduce vulnerabilities down the line. So having things like a software bill of materials and keeping good records of kind of commits and reviews and things is just the basic best practice, and good hygiene does go a long way. It's so easy to not do it. And especially if you are that one-man band and you're building this for your own use. And in some cases, it will be just that, kind of a throwaway piece, so to speak. But these things do evolve and they can become very impactful. And so setting those foundations early doors, you can make sure that the downstream effects are much more positive.
I think that's probably one of the stumbling blocks initially, because you mentioned that if somebody is doing that on their own, which often they do in a research environment, and I remember that, it's very hard to convince people to actually do it. Right. So we all know that, and I think we get it hammered into our brains that if you start doing things early, you mitigate the risks of something happening downstream. But in actual fact, not many people are doing that. So how do you convince developers then that it's good for them?
I think I would say for convincing somebody that it's working a little bit of extra now to save time in the future, because it is something that will probably come back to haunt you in the future if you don't do it early on. I think in pretty much all research projects at some stage, you will need a lot of this information. And instead of doing the mad scramble at the end where you need to get all your documentation to show it to, whether it's for a research grant or whether it's for your users, or at some stage, you're probably going to need this information. And if you've been systematically collecting it early on, just writing down the things that you're doing, documenting your processes and, your different risks and your concerns and the systems and the different things that you're doing, all the different software you're using. If you've been doing it as you go along, taking sort of a couple of minutes at each stage, it doesn't actually end up being too onerous. But if at the end you're on a tight deadline and you've suddenly got to collate all of this information 10 minutes before something's due, then it can get very stressful and you'll miss things as well that you've been doing as you go along. So I think always framing it from it's easier to do it as you're going, a little bit, as opposed to the mad scramble at the end, trying to get all this documentation together.
That's funny, because that reminds me of lab notebooks, right? I mean, because if we start a research experiment, we wouldn't go into that without any plans or just making it up as we go along. We usually have a notebook where we write down stuff that we did, how we did it, so we can reproduce the experiment maybe a little bit later. We wouldn't do that without taking some notes. So why not do it with software and with data as well, is what we're saying, really.
Yeah, absolutely.
I would like to move on and get more concrete. What are the actual key security questions that you think that people or teams in general should consider? What are the key points?
Context gathering is an important place to begin and can really steer you as well to know how in depth you need to go, because it is a spectrum. I think all cases can benefit from a light touch approach at minimum, but cases where, you probably need less convincing, but if you weren't convinced before, then if you find from your light touch risk assessment that you're using any sensitive data or anything that could be repurposed in a dual use sense, which we can talk about if that's not common terminology, or if there's plans for things to be exposed externally or used by a wide user base, then you need to start going into the more structured frameworks, really following a standardized plan through a tool. There's a number of them, like OWASP has some, which we can talk about. There's some frameworks, they all have acronyms. Stride is another one, which give you very concrete and specific things to look for, questions to ask yourself, rules that you apply. But in general, it's always universally going to be important to ask and to validate, does the system do what we set out to do? And have we acknowledged and documented any assumptions that we've made? Do we know our dependencies? Have we done, even if it's that light touch risk assessment, are all of the risks that we've identified either treated, tolerated, transferred, or terminated? So basically, we know that we have risks. Every project has risks, and we have made a plan. Even if that plan is to accept it, we have a plan to address them one way or another.
You mentioned dual use. Could you define what that actually means in that context?
So dual use is the terminology that's used by the NPSC, so that's the National Protective Security Agency, and it refers to any technology, software being a big one there, that has the potential for both civilian and military uses. And it's not always as straightforward and obvious as you might think, if you're not inclined to thinking that way. So, for example, geolocation. So that can be used for, you think of lots of things around wearables and also drone deliveries. As just a little experiment, stop, maybe pause and think, oh, how could those things be made dual use? Yeah. But when you think about it, knowing where somebody is in space and time, being able to monitor patterns of travel, being able to, any kind of control, command and control inputs or trackings, many things with AI can fall into that category as well. Lots of image recognition even. Yeah, so the list is long, and there's guidance to consider, and we can put them in the show notes perhaps, to consider if your work or your outputs have the potential to fall into any of those categories. It doesn't by any means mean don't do it either. It just means know what your risks are and develop proportionate controls to control for the risk.
I think it brings to mind something that actually makes it perhaps a little bit more realistic and transparent for people. It's not just theoretical risk assessment, because there have been cases where people have been using a very popular sports app, I think it's called Strava, and in order to locate the security detail of a president. I think in this case, it was the Russian president who was apparently in a dacha somewhere in Russia. And people knew that he was there because his security, his bodyguards basically were running around in the forest with their Strava things on, and they could be geolocated, right? And you have other examples. That's a very good example of, you may not think of that when you develop an app that uses geolocation, but if it turns out to be a very popular app for some reason or another, it could be used for that as well. So the other point I would like to make or get back to is what you also mentioned. You mentioned a couple of acronyms, and maybe we can go to that now, because we're talking about frameworks, and frameworks are there, hopefully, to help you manage all of that. Shall we start with STRIDE?
Yes, so STRIDE. The STRIDE model stands for spoofing, tampering, repudiation, information disclosure, denial of service, and escalation of privilege. And so this is a great checklist to go through in a threat modeling exercise by considering each of the 7 letters with your project in mind. You can identify your key vulnerabilities, your key threats. And once you know what they are, you can put things in place to address them. For example, spoofing refers to someone using stolen credentials or pretending to be someone else. And so by having multi-factor authentication, that's pretty easy to address. T for tampering, make sure that people aren't able to modify the code unnoticed or unchallenged. And R for repudiation, if you have audit trails in place, for example, you can make sure that you have clear accountability for who has made which changes and when. The I for information disclosure, particularly if you're working with sensitive data, so that could be health data or personal details, geolocation data even, or commercially sensitive data. You want to make sure that wherever that data is, that it's stored securely, that however it's being pulled from or pushed to other locations is all being done securely. Basic things like encryption can go a long way. D for denial of service, making sure that you're not susceptible to denial of service attacks. People can't basically flood your system and stop the availability. And then E is elevation of privilege. That's the authorization, making sure that when people are given access, that they can't then access higher levels of privilege than you would want them to. So making sure that admins are the only admins and that any kind of root access and things are really tightly controlled.
That raises a few interesting questions. The first one is, you can take a few sensible steps, is what I'm hearing from this conversation, up front without too much effort, being clear about what you want, doing some kind of documentation of what you're about to do in your research project and in your research software. But then there are the more formal, like Stride, and I think you mentioned another one, that probably require a little bit more effort. Or maybe we can talk about the tools, and that would be my second question of what kind of tools exist for that. But at what stage should teams actually consider going down the more formal route? Yeah, they probably don't want to start when they are just about to write a few lines of code, do the full Monty of whatever Stride is or the other concept that you mentioned. But at some stage they may want to, and they may want to ask, well, at what stage do I need to consider that? What would you say to that? Ellie?
So yeah, not always are you going to want to do the full Monty for looking at and going through all of the more complicated stages with these kind of things, especially again, we're coming back to our one-man band. They do take time and effort. I think it's always worth potentially going through these lists, even informally to yourself, and seeing if it brings up any questions for you and your team, if you have a team. But when it's definitely worth thinking about doing something a bit more structured and formal is, again, harping back to what we were saying earlier, is on that kind of risk assessment piece. So if you have looked and you can see that you maybe have very sensitive data at stake that is guided by a lot of legislation and regulations involved, or the consequences, of failure within your system, if there are breaches, if, it goes down or anything like that, have very bad consequences. And like Madalyn was saying earlier as well, that your work has that potential for dual use. I think it's coming back to that risk-based approach. If there is something within your development that you're creating this software that is quite risky, then it's worth looking into doing something a bit more structured and formal, like one of these, going through the full process or get more structure involved.
I mean, what you mentioned is, of course, if there's a legal requirement, right? And I'm thinking about health data in particular. Yeah. I do remember that I had a project once. I think the project was deemed, even though it was software, to be a medical device, and then it falls into a very different category where you need to have an audit trail.
Legal regulations, of course, medical device, or if you have to do your NHS data security and protection toolkit, there might be places that touch on the very clear you need to do something for the law. And then there's where it's a bit more of a grey area, a bit more nebulous, where you need to prove at the very least that you've done all your due diligence in protecting the data that's involved, or creating software that is safe, where it's maybe not exactly a legal requirement that you have to do this, but you do have to at least show that you've done your checks and your due diligence as well.
The other question that I have was the tooling and the tools themselves. So we have something like Stride. Are there any tools available that people can use in order to do that? For instance, I'm thinking that in context of many people using repository services such as GitHub, for instance, and how that would help.
Our teams use GitHub, GitLab, some flavor of Git repositories. Ellie and I don't do any of the software development or maintenance ourselves. So we don't have firsthand experience with the tools that are out there, although there are many tools out there. If you ever find yourself in a place dealing with people like us, and I mean governance people by that, people like us, we're not hard to convince. There are so many options out there depending on what it is that you're doing and the context you're working in. I would say go and look at what you think is going to work best for you. And if you need to justify it to somebody like Ellie or myself, they often make it quite easy to do that. It's in their sales pitch. Even these open source pieces. the AI tooling is coming a long way. We might touch on Project Glasswing, which is the kind of Anthropic piece that has made headlines recently, while right now that is exclusively being used by some of the very big name companies. It would be silly not to expect that we will see the downstream effects of that in due course. So I suspect that tooling will continue to get increasingly better. As with all of this stuff, huge disclaimer that don't blindly trust AI to check your code and reassure you it's all fine. But there is absolutely a time and place, and it can be a huge time saver, optimizer, if you know how to use it responsibly.
We should also say that Git repositories, whether it's GitHub or GitLab or Codeberg or whatever else is out there, also come with a lot of tools out of the box, like, for instance, License, which you can easily add now to a repository. They come with README files for documentation. And we had one guest earlier in this season, Richard Acton, who talked about checklists, for instance, which you can also use in Git repositories. So it's not about inventing new tools. There is actually quite a lot out there. But since you are talking about AI, and you just did, then maybe you can tell us a little bit more about Glasswing and how that is impacting.
For those who don't know, Project Glasswing is Anthropic's initiative to use the new Claude Mythos model to detect and patch vulnerabilities at massive scale. As you would expect with all of these things, a bit of discussion about how groundbreaking it is. Could this have been done with previous models if you had the right inputs, etc.? Maybe, maybe not. But the point is, we're here now where Mythos has identified a huge number of longstanding vulnerabilities, and in the wrong hands, this kind of tool could be catastrophic. I personally think that it is very responsible what Anthropic has done, giving access to some of the major companies first so that they can get a grip of where their vulnerabilities are, patch those, make sure that they're prepared for when this becomes more mainstream and less controlled. I think that what we will see downstream is that the expectations for everyone out of the box for security is going to be much higher, just because when this does go more mainstream, it is going to mean that bad actors and such will also have the ability to find vulnerabilities quickly and easily. And so, we need to be very, very proactive from very early doors, because we don't have the luxury of hiding, so to speak, being low profile. If you're not taking proactive measures, you're still going to be vulnerable to somebody finding and exploiting vulnerabilities in your systems. There's the positive side and the negative side. The positive being that this, I think, will make code so much better. I think that there's a lot of potential for AI to support in this area, while absolutely not going to be handing over everything to AI anytime soon, if ever, but a huge opportunity to leverage AI as a tool and as a resource. But then, it does also mean that bad actors also have tools. So it escalates things. I suspect these things will become an even more standard part of the development process, and we'll see very mainstream usage of AI tools to identify errors and improve code.
Yeah, but AI has already become pretty much the mainstay in many places for assisting with coding, at least. But it also raises another question, which is, how much do we expect people then to engage with a kind of risk assessment process if they say, well, I have an AI tool for that. So there's Mythos that can fix the bugs for me. I have some code wiping tool that creates an application for me, and all I have to do is give a few prompts and I'm done. So do you see there might be a risk, or well, maybe not a risk, but so there might be a place where in future it's harder to convince people to actually do that kind of risk assessment themselves rather than outsourcing it to AI?
I think it's definitely a risk. And I think that there's maybe shorter and medium term implications and also longer term implications. It might be easy in the short term to get lazy and let AI do it. And then we're going to see the consequences of that. And then in the longer term, I think people will find that if you can't justify how something was done, and if you don't have the accountability of how decisions were made, and if you don't have that kind of intimate knowledge of the code and how it works and why it works, it's just not going to be as good. And I think you do end up with downstream negative effects. So I would encourage people to skip the short term, relying exclusively on AI and getting lazy about your processes and go straight to the part where you've learned your lesson and you do consult expert RSEs where you're able to, and really use AI as a support tool rather than the task.
The only tool. Yeah.
Yes, exactly.
I very much agree with what Madalyn was saying. I also just think that an AI is rarely going to, well, how they are now, understand your context, your organization's context, your research project's context, as well as you do in your team. Although you can get the AI to have a look through your code, anything you've developed, and say, is there any threats here? Is there any risks here? It will pull from the standard risks, which when you're looking at software for research and in the very, very specific research contexts that a lot of people work in, sometimes the risks are a bit random and they're very, very, as we've said here, context dependent. And that's something to really keep in mind, that you are a subject matter expert working on this and your team is subject matter experts. And in the first instance, they're probably the best people to go to before you go to an AI, because truly understanding the environment you're working in, the context you're working in, is going to be done by the people that are actually in it. So again, the AI can be a great tool, great help, and very much agree with Madalyn. Instead of waiting to use it and then have problems and then realize I should have done that, myself with the AI as an assistant, skip that stage. If you don't know how something has been made and it's sort of just come from this development, you don't know what steps have been taken to get the final result, then as Madalyn mentioned, that accountability piece really isn't there. I don't know for how long people will, whether that's your boss, whether that's a regulatory body, will accept, oh, well, the AI said so, as a good excuse for when something goes wrong.
Okay, we're coming to the end now. We talked about a number of things that people could do, but as a takeaway, what are the key points that you would like people listening to this take away in terms of security and data compliance?
Yeah, so the key takeaway that I would send people off with is that security isn't just a technical feature, it's a design decision. So as we've harped on and on about, it's all about context, it's all about your particular risks. And it's something that you think about from the day you start your project through to the day where you finally reach whatever the end is. And maybe it's in perpetuity. And in that case, you never stop thinking about security. And as we mentioned before, the beautiful thing about software is it does evolve, it does change, it can be repurposed for great things as well as for not great things, which we also talked about. But the most important thing is that you know what is important to you in your project and that you have measures in place to protect that. And if there are other people depending upon your project, then their needs are accounted for as well. And at the end of the day, just by having that mindset of security by design, I think you will end up with a better project, a better output, better optimized code, better results, etc. So that's my big harp on the governance of software development and security by design.
Ellie, anything to add?
Yeah, I totally agree with all that. And then I would also just add that security is never one person's job. It's everyone's job across an organization. So even in our one-man band, everyone who is involved in a research project should be thinking about security. If you're a developer, you should be able to also, have the confidence and the knowledge to go to anyone else across the project and say, do you have any security concerns? Do you have any issues that you'd like to raise to all different people across a project or an organization? Because it's everyone's problem, essentially. If you have a security issue, everyone is impacted. So everyone should be involved. It's never just down to one person.
You will find the links to some of the tools and processes mentioned in this episode in the show notes as per usual. But now it's time for a couple of quiz questions. Number 1. Imagine you have an open source project that sits in a repository service such as GitHub, GitLab, or Codeberg. What measures can you put into place to avoid that someone puts malicious code into it? And number 2, Stride is one model of classifying potential threats to your system, but not the only one. Can you find out what else is out there? If you wish, you could share the answers using the send button in the show notes, or simply drop me an email. This is the last English language episode for this season 11 of Code for Thought. But German language speakers can look forward to one final episode next week when Florian Manzreiker, Falk Schlegelmilch and I talk about an exciting initiative in Germany called Futurize. And after that, I'm going into a little summer break until September, when the next season 12, will start. Until then, have a nice holiday, recharge your batteries, and I hope you will tune in again in September. And finally, I would like to thank the Step Up project for supporting the show and the series of bite-sized online classes. Like this podcast, we'll be bringing you a new set of classes between September and the end of the year 2026, and we hope that you will find something in there that can help you in your work. Thanks for listening. Oh, time's up. See you next time. But before I forget, this podcast is covered by the Creative Commons license. See ya.